Okay, 8.4 is about the graphs of quadratic functions. Okay, the quadratic functions is f of x equals ax squared plus bx plus c. Okay, once we graph this one, it is either concave up or concave down, or opens upward or opens downward. So the graph will be opens upward or opens downward. So this one is also called concave up. The graph is concave up. So the graph of the quadratic function is called parabola. So these are what? Parabola. Parabola. And they are symmetric across the vertical line. This is called axis of symmetry. Axis of symmetry. And the axis of symmetry is a vertical line passing through the vertical line. The vertex. The vertex. Okay, and then the graph opens upward. The right end of the graph is up. If a is greater than or equal to 0, the leading coefficient is positive, then it opens upward. The right end always goes up. And if the leading coefficient negative, then always the right end goes down. So if the graph opens upwards, it has minimum value. Minimum. And if it opens downwards, then the graph has the maximum y value. Okay, then how do you find the vertex? Okay, the vertex is this. Rewrite the quadratic expression in vertex form. Okay, the vertex form is this one. How do you write the vertex form? Okay, actually we do completing the square method. Okay, use the completing the square method. So we can use x squared, so something like this. Let's say x squared plus bx plus c. Let's say a equals 1. Okay, a equals 1. Then use these two terms. Okay, use these two terms, and using the completing the square method, we can make it something like x plus something squared plus something, right? So once we find this one, then the vertex is, okay, let's say, okay, let me just give an example like this. Okay, some number. So if this one can be written as x minus 3 squared plus 2, then what's the vertex? The vertex is, to remember transformation that we learned in chapter 4, 5. Okay, so this is a translation of x squared, translation of the x squared graph. 3 units where? 3 units to the right. Okay, x minus 3. X minus 3 means move 3 units to the right. And then plus 2. Okay, this whole thing has plus 2. Then what? Move 2 units up, right? 2 units up like this. So this vertex is 3 and 2. So this vertex comes from this 3 and this 2. So if we complete the square, then x minus h squared. So h is the x coordinate of the vertex. K is the y coordinate of the vertex. So hk is the vertex. Alright, so let's try some examples. Okay, in this example, let's find the vertex of this function. So that in order to find the vertex, we may use the completed square method. So we can write it something like this: x minus h squared plus b. Then the vertex will be h and b. Make sure this minus b, okay, minus b. If this plus b, then the x coordinate will be the negative h. Okay, so let's rewrite this function using the completed square method. So in that case, okay, plus 5, move plus 5 to a little bit further. Then we need the third part. Okay, the third constant is what? The constant is divide the coefficient of x squared. That is equal to negative 3 squared. So we are adding we are adding this number, negative 3 squared, on the same side. Same side. So we have to do what? Plus or minus, right? Plus or minus. So add the same number and subtract the same number. Okay, this is important. One is plus, one is minus, because we are adding the number, adding one number, so that we have to subtract a number. So it doesn't affect the original equation, original expression. So that is equal to, okay, the first three will make a perfect square. X minus 3 squared plus 5 minus negative 3 squared is 9. So finally, the function is x minus 3 squared minus 4. So we just rewrote the function in vertex form. Okay, vertex form. So what is the vertex? The vertex is 3 and 4. 3 and negative 4. Sorry, 3 and negative 4. Minus 3, x minus 3. X minus 3. So this 3 and the y coordinate is negative 4. So this is translation of what? Translation of x cubed graph, 3 units to the right, and then 1, 2, 3, 4, 4 units down. Right? So something like this. 3 units up, 3 units to the right, 4 units down. So this is the graph of the function. Okay, so the vertex is what? 3 and negative 4. Okay, let's consider about this vertex formula. Okay, vertex formula is a really simple formula. Okay, here is a function, quadratic function f of x equals ax squared plus bx plus c. Then the vertex, the x coordinate of the vertex is negative b over 2a. This is the x coordinate. And the y coordinate is just plug in this x value into this function. So f of negative b over 2a. So finding the x coordinate of the vertex is important. The formula is what? The vertex. Okay, for the x value, x coordinate of the vertex is what? Negative b over 2a. And the y coordinate is what? The y coordinate is just plug in this expression, negative b over 2a. So substitute this expression for x in the quadratic function. So y will be what? F of negative b over 2a. Simple. Then how did we get this x coordinate? Okay, that is, let's consider use the quadratic formula. Using the quadratic formula, set the y value equal to 0. Set the y value equal to 0. Then there are the x-intercept. So these two are the x values. So the quadratic formula gives us negative b plus or minus square root of something over 2a. Then this means, okay, if we separate the numerator, then it will be negative b over 2a plus something. Right? This something is square root of b squared minus 4ac over 2a. And then minus something, plus something, minus something. So from the vertex, okay, from this point, from this x value, we will add this much to the right. Then this is the plus something, and subtract from this x value, subtract this much, then it will be the other x-intercept. So minus something. This is b squared plus something, minus something. So this x value is the axis of symmetry, and that is the x coordinate. Okay. So can you see it again? Okay, so we have this number. This is the x coordinate. I don't know what this value is, but this value plus this much. So we have negative b over 2a. Okay, this is x coordinate of the some number x. Then add this much to the right. Then this is the x-intercept of the graph. And from this point, minus this much. Okay, minus this much, plus this much, minus this much. Then this is the second x-intercept. So the graph is what? Like this. And this is the vertex. So the x-coordinate of the vertex is negative b over 2a. So negative b over 2a. So negative b over 2a comes from the first part of the quadratic equation. First part of the quadratic equation. So negative b over 2a. Negative b over 2a, this is the x-coordinate of the vertex. Okay, then the y-coordinate of the vertex is what? Just plug in this x value into the quadratic equation. Okay, so in this example, let's find the vertex using the vertex formula. We can try using the previous method, completing the square, but it takes time. So why don't we just use the vertex formula? So the vertex formula, okay, we can find the vertex. So the x-coordinate of the vertex is what? Negative b over 2a, the first part of the quadratic equation, a quadratic formula. So negative b over 2a. So in this case, a is 3, b is negative 9. So negative 9 over 2a. So that is equal to 9 over 6, which is 3 over 2. So the x-coordinate of the vertex is 3 over 2. How about the y-coordinate? Just plug in f of what? 3 over 2. So replace this x with 3 over 2, the input 3 over 2. Then 3 times 3 over 2 squared minus 9 times 3 over 2. Then 3 times 9 over 4 minus 27 over 2. So that is equal to 27 over 2 over what? Over 4 minus 27 over 2. So let's make the same denominator, multiply both the numerator and denominator by 2, then 54 over 4. So negative 27 over 4. So this is the y-coordinate. So the vertex is, the x-coordinate is 3 over 2, and the y-coordinate is what? Negative 27 over 4. That's the vertex. So if you graph it, then what? Since we know the vertex and the leading coefficient is positive, let me write the vertex. The vertex is 2/3, I get 3 halves. 3 halves is less 1.5. And then negative 27 over 4. So let's say this is negative 27 over 4. Then this is the vertex. And since the leading coefficient is positive, the graph is concave up, opens upward, and x equals 0, then y equals 0. So it's going to be something like this. Something like this. This is the graph, but we know what the vertex is. We know the shape of the graph, the parabola, concave up or concave down. So using those information, we can sketch the graph of this quadratic function. Okay, let's find the vertex of this quadratic equation, quadratic function. In example, exercise 8. Okay, let's use both methods, using the completed square method and the vertex formula method. So using the completed square method, okay, let's do this way. Y equals, we need the leading coefficient has to be 1, so let's factor out negative. Factor out negative, then the parenthesis will be x squared minus 4x plus 8. Okay, and then let's change inside the parenthesis. So let's make it, use the completing the square so that the parenthesis will be a perfect square. So x squared minus 4x. And then what do we need to add? Okay, half the coefficients. So negative 4 over 2 squared. This is equal to negative 2 squared. So why don't we add negative 2 squared and then minus negative 2 squared? Can you see it? we added this number, so we have to subtract the same number, so it doesn't affect the original expression. So that y is equal to negative. Okay, put the bracket, and the first three terms becomes x minus 2 squared, and then minus 4 minus negative 2 squared is 4 plus 8. Then y is equal to negative bracket x minus 2 squared plus 4. Alright, then let's clear this bracket. Clear the bracket, then it becomes what? Negative, multiply this square by negative, and then 4 by negative. So that will be y equals negative x minus 2 squared minus 4. Alright, so from here, okay, so we rewrote the quadratic function in standard form, in a vertex form. So from here, the vertex is what? Vertex is x minus 2. So x coordinate is what? 2. And y coordinate is negative 4. So this is shifting x squared, negative x squared what? 2 to the right, 4 units down. So this is the vertex. Okay, how about using the vertex form? The vertex formula. Okay, this is completing the square method. Completing the square. Okay, completing the square method is this one. And now we're going to use vertex formula. So the x coordinate of the vertex is what? X coordinate of the vertex is equal to what? Negative b over 2a. So negative, and then b is 4 over 2 times a. What is a? Okay, a is negative 1, b is 4. So negative 1. Then this is equal to positive 4 over 2 equals 2. So the x value is 2. How about the y value? Y value is f of what? F of 2. Then plug in 2. So negative 2 squared plus 4 times 2 minus 8 equals negative 4 plus 8 minus 8. So that is equal to 8 minus 8 cancel out, negative 4. So the vertex is what? X value is 2, y is negative 4. So this is same as the one that we found earlier. So that is the vertex. So when you write a vertex or point, you can write a capital letter V and then parenthesis, the order pair. Okay, for exercise number 10, we will do the same thing. So let's use both methods, the completing the square method and the vertex formula. Alright, then completing the method, completing the square method. Okay, in this case, the leading coefficient is not 1. So why don't we factor out 3? So that we have parenthesis x squared minus x minus 3. And then let's make a perfect square inside the parenthesis. So using, okay, let me write it here, minus x, and then put some space, bracket. Bracket or space, parenthesis doesn't matter. Okay, what goes to the blank? Okay, the leading coefficient is negative 1. So that will be negative 1 over 2 squared. So plus what? Negative 1 over 2 squared, and then minus negative 1 over 2 squared. So one is plus, one is minus, because they are in the same side. So that y equals 3 bracket. The first three terms will make it x minus 1/2 squared minus, okay, this is equal to 1 over 4 minus 3. So y equals 3. Let's simplify the bracket. And adding this 2 is what? 1 over 4 minus, can multiply both top and bottom by 4. It's 12 over 12. Okay, still more. X minus 1 over 2 squared. Okay, this gotta be 4, right? 4. So negative 1 minus 12 is negative 13 over 4. Now distribute these two. Then y equals 3 times x minus 1 over 2 squared minus 3 times 13 over 4 is 39 over 4. Okay, so from here the vertex is what? The vertex is x minus 1 over 2. So x coordinate is positive 1 over 2. Y coordinate is negative 39 over 4. So this is the vertex. Okay, now let's use the quadratic and the vertex formula. Okay, the vertex formula is what? Okay, use the vertex formula. Then for the x coordinate of the vertex is what? Negative b over 2a. So negative b is what? B is negative 3 over 2 times a is positive 3. So that is equal to, okay, 3 cancel out, negative positive, 3 cancel out, 1 over 2. So x coordinate is 1 over 2. How about the y coordinate? Y coordinate is what? F of 1 over 2. So 3 times 1 over 2 squared minus 3 times 1 over 2 minus 9. Then that is equal to 3 times 1 over 4 minus 3 over 2 minus 9. Then that is equal to, okay, so 3 over 4 minus, multiply 3 and 2 by 2, then 6 over 4 minus, multiply 9 by 4 is 36 over 4. Multiply both top and bottom by 4. So finally, 3 minus 6 is negative 3. So negative 3 minus 36 is negative 39 over 4. So the vertex is equal to what? The x coordinate is 1/2, y coordinate is negative 39 over 4. So we get the same vertex. Okay, in this example, we will see how we can sketch a parabola, the graph of quadratic equation. Okay, first we gotta find out the vertex. Using the vertex formula is better. And then once we find the vertex, we gotta find the x-intercept and the y-intercept. Okay, y-intercept is easy. We just set the x value to 0. Okay, for the y-intercept, how do you find y-intercept? Set the x value to 0, then you get the y values. How about the x-intercept? Set the y value to 0, then you get x values. So for the x-intercept, sometimes it will be hard, but we know, approximately what the x-intercept is. Okay, and then connect all these 3 points. So if the leading coefficient is 0, then it should be concave up. The graph should be concave up. If the leading coefficient negative, then the graph is concave down, opens downward. So connect all those points that we found. So let's try example 1. Okay, in order to graph this quadratic function, okay, let's find the vertex. Let's find the vertex. So the x-coordinate of the vertex is what? Negative b over 2a. Use the vertex formula. Okay, negative b over 2a is the front part of the quadratic function, quadratic formula, right? Quadratic formula. So negative b minus 6, negative 6 over 2 times 1. So 6 over 2 is 3, so negative 3. How about the y value? Y value is f of negative 3. So negative 3 squared plus 6 times negative 3 plus 8. Then this is equal to 9 minus 18 plus 8. So that is equal to, negative 18 plus 8 is negative 10, so negative 1. So the vertex is what? X equals negative 3, y is negative 1. Okay, so we found the vertex. Okay, let's find the y-intercept. Okay, y-intercept. Okay, for the y-intercept, we set the x value to 0, right? Set the x value to 0. So if x equals 0, then what? 0 plus 0. Okay, So y equals what? 0 plus 0 plus 8. So that is equal to 8. Y-intercept is really easy. Just plug in 0 for x, then y is 3, 8. Okay, the x-intercept is hard because we gotta set the y value to 0. Then y is 0, then what? Okay, so 0 is equal to x squared plus 6x plus 8. Okay, so this is y, right? The function is y. And we're gonna set this one is equal to 0. Then you can find x using, if this is factorable, then use the factor. If it's not, then you can use completing the square method or quadratic formula. And this one is factorable because x times x, 2 times 4 is 8, the sum is 6. So this is equal to x plus 2, x plus 4 is equal to 0. X plus 4 is equal to 0. So x equals -2 or -4. So there are two x-intercept. One is -2 and the other one is -4. -4. Okay. And then what is the leading coefficient? The leading coefficient is 1. The leading coefficient 1. So the graph should be concave up because the leading coefficient is greater than 0. Then the graph will be, okay, let me graph it over here. Okay, the vertex is -3 and -1. 1, 2, 3. -3, -1. So this is the vertex. If x equals 0, then y equals 8. Let's say this is 8. And the x-intercept is -2 and -4. This is -4. So -2 and -4. So passing these two x-intercept, and this is not drawn perfectly. So let's say this is negative, this is positive 8. This makes more sense. Okay. So let's connect the points. And then we know the graph is concave upward like this. It's got to be a reasonable graph, right? Something like this. Okay, so this is the vertex. The vertex is -3 and -1. This y-intercept -2, -4, x-intercept, sorry. And this is the y-intercept 8. So sometimes this is not factorable. Sometimes when you find the x-intercept, this may not be factorable, then what? We gotta use quadratic formula. It's gonna be tough, huh? Tough. So sometimes you don't have to specify the x-intercept because sometimes it is hard to find out. It takes time. Okay, in this exercise, let's graph this one. So let's find the vertex and the x-intercept and y-intercept. Okay, so the vertex is what? Okay, x value for the vertex. The x value is what? -b over 2a. And then -b, b is 0 because there's no x term. Okay, no x term. So since there's no x term, which means 0x, right? 0x. So actually the x term is, the coefficient of x is 0. So b is 0. So -0 over 2a, which is 0. So the x value is 0. How about the y value? F of 0. If x equals 0, then y is 9. So the vertex is 0 and 9. I'm sorry for the dog barking. Okay, how about the y-intercept? Okay, y-intercept is when x equals 0. Y is what? X equals 0, then y equals 9. How about x-intercept? X-intercept is when the y equals 0. So if the y is 0, then what is x? Then move x squared to the left. It equals 9, then x equals plus 9. Square root of 9, so 3 or -3. Okay, let me write one more step. So x equals plus or minus square root of 9. So x equals 3 or -3. So there are two x-intercepts, 3 or negative 3. So let's plot this point. X, Y. Okay, the vertex is 0, 9. 0, 9, this is the vertex, 9. And here is 3, x-intercept is 3 and negative 3. And we know the leading coefficient. Okay, leading coefficient is what? The leading coefficient is less than 0. The graph will be what? Concave down. So this makes sense. Concave down. Right, so this is the graph. Okay, or can you think about this? Isn't it? Translation of negative x squared. Translation of negative x squared, 9 units down. Okay, translation of negative x squared, 9 units up, right? Plus 9 is up, not down. So, if we know the transformation, we can do this way. This is x squared, right? X squared. And then negative x squared is what? Flip, reflect across the x-axis. This is negative x squared. And then plus 9 is what? Move this graph 9 units up. 9 units up like this. So this makes sense. Okay, from this exercise 22, what is the vertex? The vertex is, okay, already this function is written in vertex form. So isn't it same as plus 0? Plus 0. So h is what? H is negative 4 because this is plus. So the x coordinate is what? Negative 4. And y coordinate is 0. So that is the vertex. Why negative 4? Because this is plus. So change the sign. Then negative 4. Okay, so the graph will be... Okay, how about the y-intercept? Y-intercept is when x equals 0. What's the y value? X equals 0, then y equals negative 4 squared, so that is equal to negative 16. Y-intercept. Okay, so the vertex is negative 4, 0. It's negative 4. That is the vertex. And the y-intercept is, oh, wait a minute. Get the vertex negative 4, 0, then x equals 0. Wait, oh, this is something wrong. Let me think about this one. Right, why did I write this one? This is not right. Okay, x-axis, y-axis. Okay, so the vertex is negative 4, 0. So negative 4, 0 is 1, 2, 3, 4. Let's say this is negative 4. So this is the vertex, right? Vertex. And the y-intercept is negative 16. So let's say this is negative 16. And then we know that a is less than 0. So the graph is concave down. So it's going to be something like this. Right, like this. And look at this x-intercept. There's only one x-intercept, right? Yeah, because if you want to find the x-intercept, then set the y value to 0. So this is equal to what? Now multiply each side, move this one to the left, or multiply by 0, then what is x? From here, x equals negative 4, right? Negative 4 and negative 4. Negative 4 and negative 4. So there is one x-intercept negative 4. So that is correct. Okay, in this example, okay, we will find the equation of the parabola. Okay, in this case, the vertex and y-intercept is given. Vertex and y-intercept given. So it's important that the vertex is given. Since the vertex is given, we can use the vertex formula. Okay, what's the vertex formula? Okay, the vertex formula is a times x minus h squared plus k. This is the vertex. And then the vertex is what? hk, right? hk. So we can substitute, negative 2 and the vertex is given negative 2 and 1. Substitute negative 2 and 1 for h and k. So we can write it as this. A times h is what? Negative 2. So x minus negative 2 squared plus 1. Then f of x is equal to a times x plus 2 squared plus 1. So we have a quadratic equation in standard form, but in this case we gotta find a. Okay, a. So in order to find a, we need 1 point. Already we used up the vertex. So why don't we use the y-intercept? So using this y-intercept, we can find a. So x equals 0. When x equals 0, y is negative 3. So use the y-intercept to find a, right? So the y-intercept is what? 0 and negative 3. So x equals 0, y is negative 3. So y is negative 3, so that f of x is negative 3 is equal to a times 0 plus 2 squared plus 1. So from this equation, let's find a. So negative 3 equals, okay, a times 2 squared is 4 plus 1. Then this is equal to negative 3 equals 4a plus 1. Minus 1 each side. Then negative 4 is equal to 4a. Divide each side by 4. So negative 1 is equal to a. And negative 4 over 4 is equal to a. So what is a? A equals negative 1. So replace this negative 1, a with the negative 1. So finally, our equation is what? F of x is equal to a is negative 1. So negative parenthesis x plus 2 squared plus 1. So this is the quadratic equation that satisfies the information, vertex and the y-intercepts. Also the graph will be, once you graph this, then it will be same as the graph shown. So it's very important. Vertex is given, then write quadratic function in vertex form or standard form. Then just replace this h and k with the coordinate of the vertex. And then find a, the leading coefficient. Find a using another point that is given. Okay, let's write an equation of this graph. And in this graph, there are 2 points given. One is the vertex and one is the y-intercept. So since vertex is given, we have to write a vertex form first. So the vertex form is what? F of x equals a times x minus h squared plus k. And since the vertex is negative 1, 0, we will replace this h with negative 1. So x, this is the x value. I'm sorry. Okay, this is the h value and this is the k value. So f of x is equal to a times x minus negative 1 is plus 1. Okay, minus negative 1. Let me write one more step. Plus k equals 0. So f of x is equal to a times x plus 1 squared. Alright, then we gotta find this a. How do you find a? Okay, use another point, which is this point, and this point is the y-intercept. So x equals 0, then y is negative 1. So use this point. Use this point. That means x equals 0 and y equals negative 1. So from here, y equals negative 1. A times x is 0 squared. Then negative 1 is equal to a times 1 squared. So a equals negative 1. Is negative 1. So finally, our equation is what? The quadratic equation is f of x is equal to a is what? Negative 1. So put the negative sign instead of negative 1, just negative. then x plus 1 squared. Okay, so that is the quadratic equation for the graph. Okay, let's try number 28. The method is exactly the same. So this is x-axis, y-axis, and the graph here is 1.00, and the vertex is -1 and -2, -1 and -2. So from here, let's find the vertex form. Okay, a times x minus h squared plus k. And the vertex is -1 and -2. So plug in h and k values. X minus, okay, h is -1 squared, k is -2. So that f of x is equal to a times x plus 1 squared minus 2. And then we need to find a. So let's use 0, 0. Okay, use 0, 0. So this will give you y equals 0. And then x equals 0. So 0 is equal to a times 1 squared minus 2. Then 0 equals a minus 2. Move negative 2 to the other side, and positive 2 equals a, so that a equals 2. So finally, our function is what? The function is equal to a. A value is 2, x plus 1 squared minus 2. So from here, we get the quadratic equation. Okay, let's do another example. Okay, the vertex is 2 and 2. So f of x is equal to a times x minus h squared plus k. And the vertex is 2 and 2. So plug in h and k. Replace h and k. So f of x is equal to a times x minus h is 2 squared plus k equals 2. And then let's find this a. So use what? Use the point 0 and -2. So y equals -2, a times x equals 0. So this is equal to -2 is equal to a times -2 squared is +4. So -2 each side, and -4 is equal to 4a, and divide each side by 4 equals a. So now a equals -1. So finally, our equation is what? Equation is f of x is equal to a is -1, so negative x minus 2 squared plus 2. Using the transformation, negative x squared, move this means, actually we can do this way, right? Move this one 2 units to the right, 2 units to the right, and then 2 units up, like this. So, this, makes sense. So this is the quadratic function that represents the graph. Okay, in this example, okay, vertex and 1 point is given. So write an equation of the parabola that passes through the vertex and this point. And this point is not y-intercept or x-intercept, just 1 point on the graph. So since the vertex is given, we gotta use the vertex formula. So first, always write the vertex formula first. So the vertex form is what? F of x equals a times x minus h squared plus k, and the vertex is 3 and -4. And then plug in these values for h and k. So f of x is equal to a x minus 3 squared, k is -4, so -4. And then find the coefficient, the leading coefficient a. So how to find this a? Use the other point that is given. So which one is given? 5 and -2 is given. So x is 5, y is -2. X is 5, so 5 minus 2 squared minus 4. Then -2 is equal to a times 3 squared minus 4. So -2 equals 9a minus 4, and plus 4 each side, so 2 equals 9a. So from here, a is equal to, divide each side by 9, so 2 over 9. So we got this a value. So the function is what? The formula is the quadratic equation is f of x equals 2 over 9 times x minus 3 squared minus 4. Okay, so it's not hard, just use the vertex. Vertex is given, so use the vertex to write quadratic equation in using the quadratic the vertex form. Okay, write in vertex form first, and then find a using the other point. Okay, this exercise 32. Okay, vertex is given and a value is given. All right, then let's find the quadratic equation in vertex form. So f of x is equal to a times x minus h squared plus k. And h value is what? Okay, a is 1, so we can plug in 1. And x minus h is negative 3 squared plus 3. So finally, f of x is equal to x plus 3 squared plus 3. Pretty simple, this one. How about 34? Let's try 34. Okay, 34 is, the vertex is, okay, 34 is the vertex, negative 2 and negative 4. The point is 0, 0. Point is 0, 0. Okay, so let's write the quadratic equation in vertex form. So x minus h squared plus k. And then replace this x, h and k. So h is negative 2. And k is negative 4. So f of x is equal to what? X minus negative plus 2 squared minus 4. And then we got to find a. So why don't we plug in 0 and 0 for x and y? So y equals 0, x equals 0. Then 0 is equal to a times what? 2 squared is 4 minus 4. So 4 move negative 4, so plus 4 each side. Then 4 equals 4a. So a equals finally 1. So our equation is what? F of x equals 1 times, so we don't have to write 1, x plus 2 squared minus 4. Okay, this is a word problem. The example 6 is about the bridge. Okay, there are two towers, and the cable connecting these two towers is in parabola. It's parabola. Okay, so it has a vertex. So why don't we put the vertex in the center? Okay, put the lowest part in the center of the xy coordinate plane. So this center is 0, 0. So this is the vertex. And the towers are 600 feet away from the center. And the height of the tower is 152 meters. All right, then what is the formula? Okay, we're going to write an equation that models the cable, this cable of this bridge. So since we know the formula, since we know the vertex and 1 point at least, so we can write the equation in vertex form first. So the vertex form is what? F of x is equal to a times x minus h squared plus k. And h and k are the coordinate of the vertex. The vertex is what? 0, 0. So plug in 0, 0 so that we can find, we can write the equation in vertex form. So a times h is 0, k equals 0. So f of x is equal to a times x squared. All right, we have this quadratic equation. Then we got to find the leading coefficient a. So in order to find this a, we have to use 1 point. So why don't we use, this point? So use what? 640 and 152. So plug it in here. So y is 152, x is 640 squared. And then, okay, so 152 equals 8 times 640 is, use the calculator. So then it will be 51,200. So A is equal to 152 over 51,200. So the equation will be what? Finally, the equation is what? F of x is equal to A is 152 over 51,200 x squared. So the parabola of the graph of the cable can be written as this.